All right, we're live. Hi, everyone. Welcome to the July Research Showcase of the Wikimedia Foundation. My name is Leila Zia. I'm the head of research at the foundation, and I have the honor of hosting the session today. We have a very exciting research showcase for you that I'm going to come back to in just a moment. Before that, I would like to make a couple of announcements for the upcoming showcase in the coming months, and also some logistical announcements for the call today. We are joining this call remotely. A lot of you are watching this video later on. For those of you who are watching this live, you are welcome to share your questions with us in IRC, Wikimedia Research Channel on Libera, or on YouTube if you're watching the video live on YouTube. My colleague Isaac Johnson will gather the question and then ask them in the room. If you're in the room, you're welcome to raise your hand and ask your questions in the room. This is for the logistics of the call. And other than that, I just wanted to make an announcement that in August, we are not going to have our usual research showcase. This is actually a tradition that we have been following in August, that we usually cancel the research showcases, and instead we attend Wikimania, which is the largest Wikimedia conference of the year or event of the year. So that's what we're going to do in August. Please join us. Look for Wikimania 2022 in the browser of your choice, and see you there with the rest of the Wikimedia communities. With that, I'm going to switch to today's showcase. So we have a special edition today where we have the opportunity to hear from the award, Wikimedia Foundation Research Award of the Year 2022 recipients. We have two of the researchers here in the room with us, Krishna Srinivasan and Gabriel Maya, who are here to present their research and the research of their collaborators. I'll tell you briefly a little bit more about the Wikimedia Foundation Research Award of the Year. This is an award that we have been given over the past couple of years for outstanding research that has the potential of significant impact on the Wikimedia projects. For this year, Benjamin Mako-Hill and I were the award co-chairs, and we reviewed more than 230 publications that were published during the year 2021. And from all these amazing publications, we chose two to be awarded. We have two categories of award for this year. One is the Wikimedia Foundation Research Award of the Year, and then the other one is the same award, but for the best student paper. And this is, as is customary, is for the paper that at the time of publication, the first author of the paper is a student. You will hear from both speakers and presenters in this call. I'm very excited for us to have this opportunity to have more in-depth presentation by the two researchers, because in the award ceremony, we primarily get a chance to celebrate their work and not so much hear from them. So with that, I'm going to pass it to Krishna to present their collaborators' research. Krishna, please.
Thank you very, very much, Leela, and thanks to Wikimedia Research for inviting us. Let me share my screen a second. Are you able to see my screen and hear me okay?
Yes.
Just a second. Hi, everybody. I'm Krishna Srinivasan. I'm here to talk about our work, Wikipedia-based Image Text Dataset for multimodal, multilingual machine learning.
Sorry, Krishna, I hate to disrupt you, but we can't see your slides.
Oh,
I think maybe you stop sharing your screen.
Just a second.
There we go.
Are you able to see this now?
Yes.
Well, thank you so much. Yeah. So very briefly, the agenda, I'll give an introduction about ourselves, talk about the multimodal data sets, which will set the context for our work, talk about the WIT dataset itself, some image text retrieval experiments leading to our journey, and future work and challenges that we are very excited to consider and work on. Introduction. So this is our team. I'm very honored to present this on behalf of Karthik, Jacob, Mike, and Mark, and many others who helped behind the scenes to put together this amazing work and data set. So the motivation for the multimodal multilingual data set. Shakespeare said brevity is the soul of wit, but machine learning models, brevity is definitely not the thing to go for. They need as much data as you can give them. The more high quality the data, it is better. If it's human verified goal labeled data set, then all the more better. And they also like multiple contexts. So in real world, we have audio, video, images, text, everything put together. But normally machine learning work has been mostly in the NLP, which is only text, and then or it's in the vision where it's only images. So this exciting new world of multimodal, where we try to use multiple modes, in this case, image and text, put together and to be able to enable the model learn better. And of course, not to forget that we want this to be multilingual learning, not primarily in English, which is where most of the data and models are traditionally done. And last but not the least, we want it to be very entity rich and a knowledge based data set, not anything that's talking about the trivial things over and over again. With that, a very brief introduction to some of the multimodal data sets that were there when we started our work. One of the oldest is this Flickr 30K data set, where Flickr.com website chose 30,000 images and gave it to human judges and asked 5 of them to come up with one caption each. And thus you get an image and a description what the judges think the image describes about. Here's an example, which is great. And then came SBU captions dataset. They went for a much larger dataset size. They took the Flickr queries and then they did the same thing by trying to find out the context around the Flickr page on a particular web page, the Flickr image on the web page. So it's a slightly bigger dataset, but again, going to the web instead of now the human editors. Then there is one more called Microsoft Common Objects in Context. This is an order of magnitude bigger than Flickr. It's 330,000 images. And this one is captioned by human judges as well, but only one caption per image and 5 captions per image, but it's 300,000. Now it's like a much larger data set. The important factor is here they came up with like a bunch of categories, about 91 categories, and the images were all chosen within this particular selection. So again, now we switch to the web mode, conceptual captions, in which case there is the version 1, 3.3 million, and there is a later one that came out with 12 million images. In this case, the clever idea was to crawl the web, figure out images, but use the alt text as the caption. And then it goes through exhaustive filtering pipelines to make sure that the image and text alignment is there to come up with this. So when we were looking at this, individually, the images dataset were getting very bigger. Text datasets, of course, there is the whole Wikipedia, which is a super popular dataset for all kind of NLP models. And then there is additional datasets that were being put together. But image plus text put together was around this size. And the tasks that were being used to train these models started getting more and more complex. So it started off with image text retrieval, and then it went to writing a caption for an image, visual question answering, and I will explain a little bit more about these tasks later. But there were like all this common sense reasoning, general question answering or visual question answering tasks that made the models challenged because of the very limited data set. So here is a very rough comparison of where the various data set sizes are. And that leads us to our motivation. Would we be able to build a bigger data set, but retain the very high quality and at the same time make it very multilingual and spread across a vast variety of categories and topics? Voila, Wikipedia. should not be a surprise here. Wikipedia is very big, 50 million plus pages. It's free in every spirit of the word. It combines the aspect of human curation, so you get this extremely high quality that it's created and constantly edited and updated by humans. But at the same time, it is very close to web scale with this millions and millions of pages and images. And very importantly, it is multilingual. There is 250 plus languages, popular ones that there are thousands and thousands of pages upon. And all of this is on top of knowledge base, which is very, very entity rich. The knowledge base is encyclopedic. So this was our motivation. So how do we combine the scale of web crawling, but at the same time not compromise on the quality of the text? So let's look at an example. One of my favorite parks here, Half Dome Yosemite National Park, Half Dome Peak. So this is the Wikipedia page for that Half Dome. And you would notice that the page is already beautifully laid out. It follows various pages follows a very consistent notation of having a title, a description, image, what's called a reference description. And then if you click on the image, you get to see a lot of metadata about the particular image. And this is all very nicely laid out for every single, this is just like the top image. But if you scroll down the Wikipedia pages, you see more images, all with such surrounding nice information. A short digression, that's me, the tiny figure in the middle on top of Half Dome a few years ago. It was a very, very strenuous hike, but super awesome views from the top. And it was very, very scary to go to the edge and post like that. I had to literally crawl on my rear end to go to the edge, pose, and then immediately walk back. But anyway, back to the important talk. So now we take this particular page, we crawl and parse the particular page for this salient information. So you have the image, you have some metadata about the image, you have the URL and the page title, and then it gives you the various captions and what the page is about, what the section is about. You put it all together in a nice format, and you get a very structured database row, and combine all the rows, you get a nice data set of it. So with this, because of the scale of Wikipedia, and we were able to create this massive data set, which is 37 million image test examples with 11.5 million unique images across 108 languages. We could have gone to way more languages, but we wanted to make sure that each language we chose had at least 10,000 examples. So it will be enough, significantly enough to for a model to learn about that particular language. So by the time when we were creating the data set, we were an order of magnitude bigger than any other data set. And this 37 million is also very conservative, because each image, because of Wikipedia's multiple captions that there are for a particular image, this number is much bigger. There are more captions than this. This is 37 million rows. So with that, a little bit more about the data set. So this is the reason why we picked these particular parameters. And there are plenty of entities, 600,000 plus unique entities that are being mentioned across 108 plus languages. And in addition to that, what makes WIT dataset very unique is that this is the only dataset that has all the contextual information. So there is the whole Wikipedia page title, description, the section it is in, the section title, and so on. But there is a lot more data surrounding in the complete page, and those power is yet to be truly tapped. So now we have the table with the comparison of the various data sets. So WIT is now one of the biggest publicly available data sets out there for multimodal research. Very briefly talking about how we created. So we started with all the Wikipedia pages, choose the ones in which there are salient images, make sure that they are in the main section of the pages, collect the data along with the URL, title, description, and the image metadata. And we started off with like 124 million plus images. But then we generated all these various tuples and filtered it on many different axes. One, we filtered it based on the images. Is the image size, is it like, sometimes it could be a small fave icon or a logo. So we wanted to make sure that the image was big and usable with the right license. And then on the text side, sometimes the captions could be empty or it could be a single word. And then so we had to make sure that the text was usable as a caption for a given image. So with all that, we created this data set, but we wanted to make sure that the quality was still very good. So we took a tiny subset of the data, took the title and image, some captions, and spread it across English and other languages. And we asked 3 human raters, given a template like this, here is the image, here is the title, and here are the 3 captions. Would you rate it that the image and text have good alignment? And no surprises there. Overwhelmingly, more than 94% of the image text that we chose came up with a resounding thumbs up. So we were super happy with the quality of the data set we were about to release. And so we started doing some image text retrieval experiments as a starting point. So in this case, what do we do? So given a caption, you want to find the right image, or given an image, you want to find the right caption. So we chose a couple of test sets from the popular Flickr 30K and MS Coco. And we use what is called a dual encoder model, which is very popular for retrieval type. In one tower, you learn about the image and you encode the image. In another tower, you learn about the text caption and encode the text caption. And you find the cosine similarity between the two to make sure that they are well aligned. I wouldn't go too much into the experiments. I'm happy to answer this during the questions. We did very well. No surprises there on the WIT data set. But we also saw that, like, when we were training on other sets and you give them a WIT test set, it was very hard for them because, one, the data size is smaller on the other data sets, and 2, the knowledge base and the entities are not as big. So I would call your attention to the 2 tables, table 10 and table 11. So one is the vocabulary comparison. We compared it to the previous big data set that was out there. And you could see that 72% of the words occur less than 3 times. So that shows how wide and vast and powerful the Wikipedia's knowledge basis on the text axis. The second thing is, when we were comparing it against the test sets, we could again observe the same distribution of words and entities that makes it very hard as a test set. So in turn, it makes it very hard for a model to be trained on, which then makes the models really powerful and takes us towards doing much more variety of tasks in a much more efficient manner, where the models learn true world knowledge. So with that, a very short memory trip down the memory lane, if you will. So once we had the WIT data set, we were super fortunate to be acquainted with wonderful folks from Wikimedia Research. So along with Miriam and Leila and a few others, we thought about organizing an image text retrieval challenge. So we partnered with Kaggle, and we took the validation and test sets of the WIT dataset, which we had not released, thankfully. And so we kept it, and then we chose an image text retrieval challenge competition. And thanks to Wikipedia, so we have about 70% of the images available as pixels, as well as a ResNet embedding that's downloadable and ready for use for anybody with one click. And on top of this, we took the challenge as one of our motivations and organized a workshop that was co-hosted at iClear a few months back, where the theme was again multimodal, multilingual machine learning. It was an amazing experience to be able to do that. The Kaggle test challenge itself was a fantastic experience. 105 plus teams participated. They came up with a new state-of-the-art score, and a few of them even presented at our workshop. And I would also like to then take this moment to give our heartfelt thank you to Wikimedia Research for recognizing our work and encouraging us this way. So thank you on behalf of all of us. So with that, we got a lot of experience creating a data set, doing a competition, conducting a workshop, and so on. And more than happy to share the experiences during the Q&A or even offline. With that, here are some of the important links for the white paper, the dataset, related research, the Kaggle competition, and so on. And we are always happy to collaborate. Feel free to contact us anytime on a related work to that. With that, very briefly, I want to touch upon some of the future challenges that we could be handling and focus upon. One is that the Wikipedia data is very, very rich. So we have just touched the tip of the iceberg with image plus the text caption as the task, even though even more information is provided in the form of contextual data. But even beyond the contextual data that we have provided for each image text, there is still more information. There is the links, the anchor text. There is the link graph and the page graph connecting various Wikipedia entities and pages. There is knowledge panel and tabular data in all the Wikipedia pages that could be talking about something. So combining all this would make a very, very powerful generalized model beyond just the image plus text. The next area of research that's right for looking at would be cross-lingual captions. And this closely ties to one of the facts we observe, like 50% of the Wikipedia dataset and roughly the WIT dataset that we created out of Wikipedia is like English. And then the remaining 50%, you would notice a power law distribution. The next 10 languages take up about another 40 to 45%, and then it progressively falls down very steep. So there are hundreds of languages, if not thousands, that need more content, and those content pages need more images. Irrespective of this underrepresented languages, there are still millions of pages that could use more images to better convey the knowledge of the Wikipedia page. And in addition, for the pages that have images, there are again millions of images that need captions. So these are all super interesting problems that are right now very hard, and if solved, could directly feed back to Wikipedia to be able to enhance the world knowledge. And this could be accomplished with a lot more advanced tasks, like there is a visual question answering or a general question answering. And I will give a couple of examples to this in the next slide. So I just want to talk about that. It's not just the image and text alone. There is also audio and video modalities that could be used now to get a much better whole page understanding and a knowledge understanding. So what I was alluding to a bit earlier, so these are some of the visio-lingual tasks. The retrieval one is a very popular one that I described about, but some of the other things could be what is called a referring expression, where you can point to some region in an image and say what's happening there. Or it could be the visual question answering, where you ask, is there something to cut the vegetables with? So you have to understand the question, understand the image, and know that a knife is the object that's need to cut, and then infer that the knife is in the particular image. And similarly, there could be more complex reasoning questions or general question answers, which ask the model to learn to reason about the text, the question, as well as the images. So here is like a whole bunch of various different tasks that these models could be trained on. So we have all the tasks, and we have like models that have been improving by leaps and bounds. And we have Wikipedia. So we can create all this massive, wonderful, challenging data sets and tasks by which the models can learn much better representation of the real world and of the knowledge. So with that, I thank you all very much for listening. Thank you for giving us an opportunity to present this work. Thank you so much.
Thank you so much, Krishna, for your presentation. I'll first go to Isaac to see if there are questions from YouTube or IRC or from the room that you have spotted.
No questions yet from IRC or YouTube or the room.
Okay, thank you. So then maybe we can open it to the room for now. If you have a question, please unmute and ask.
I think I'll go ahead. Krishna, I want to start just by thanking you and the team for the work, and especially because I don't think it was very obvious, and given that your team would withhold test and evaluation data set after publication to CIR, to a resource track, to allow all of us to do this competition for the community and also for the amazing collaboration. So first of all, I want to thank you and the team for the work. The award is super well deserved. I am very happy that you can share further your research. So I think maybe one interesting aspect that maybe the audience might be happy to hear is about the challenges around putting together a competition, and actually the challenges that the competitors found when dealing with such a large scale multilingual data set. And during the workshop, we have been discussing with them. So I think it is interesting to hear them and also collectively think about how to come up with solution and support the communities dealing with such massive scale data set. And thank you.
Thank you so much, Miriam. Likewise, all the pleasure. It was great collaborating with you to put together this challenge. And thanks for making the image pixels available. There is not a week that goes by where at least there is one or two inquiries where somebody say, hey, how do I get all these images? You created this big data set with 11 million plus images, but it's not possible to download. Providing them a very easy way to download definitely takes this, makes this much more accessible. The text part people are able to download fairly easily and process, but the images definitely is something where such a help is greatly appreciated. I would thanks so much, and again urge to make such image datasets available more. So to answer your first part of the question regarding the two challenges, one with the dataset and another with the competition and the challenge. So with the dataset, to be very honest, we initially thought it was going to be straightforward. We take the dataset, we create a big list of rows and then release. But then little did we realize how much of filtering and curation we had to do to make sure that the image text alignment quality is very good. And this is considering that this is starting from Wikipedia, which is already at a very high quality to start with, but we wanted to make sure that when we give an image that there are all the captions there, or the captions are not like a particular file name or a single word, that it is actually a real entity. And then of course, Wikipedia is all knowledge. So we wanted to filter out certain topics that might not be appropriate for general research. So we had to do those type of filtering before we created the data set. On the and I believe there could be a lot more that could be done where we could now start and do this process more quickly now that we know what are all the various things we are looking for. But on the challenge side, once again, it was a big surprise because like with Kaggle, the moment you announce a monetary reward, which we were all initially considering, it becomes more competitive. And there are some people, unfortunately, who try to then game the competition. The machine and the models don't learn. They just figure out how to beat the metrics. And Wikipedia being open and popular, if you give them a test set, people could literally go search for it, figure out what the caption is, and make it a human task, mechanical Turk type of task, rather than a machine learning task. So we had to be aware of that, thanks to the folks from Kaggle who also made us aware of all these various challenges. And to still make it interesting enough that we were able to provide the images text all in one places. And then one learning from that for us was that in the future, if you are doing competitions, more such available resources to download. But another thing we could also do is use Hugging Face, create a pre-trained model and have it all ready, and an example collab. This is the first time we were doing this competition as well as a collaboration for workshop. These were some of our lessons. So the next time we do, we will have a ready-made starting point for many more researchers where they can one click and they already have the baseline model and test set everything ready, and then they can innovate on top of it. So it will encourage more wider participation. The second thing I just want to quickly add is the next time also as we were talking about earlier in our collaboration, is to make the tasks more challenging. For example, image captioning. It's going to be much harder to do judgment on a caption, but if we can do that, figure out how to judge that properly, like captions for images or coming up with images for pages, then that competition directly results in some very good output that can directly be used for enriching Wikipedia knowledge. So I'm super excited about the possibilities. I can talk about this endlessly, but I'll stop here.
Thank you so much, Krishna. Maybe we can take one more question, either if there's a question on YouTube or IRC or in the room. Go for it, Isaac.
All right. Yeah, thanks for the presentation, Krishna. Some really interesting stuff. And having worked with a lot of data and trying to clean data from Wikipedia and Commons, I know the amount of work that sits behind something like this. My question was around the modeling, and I know you shared a number of different tasks, but I guess the one that maybe I'm most familiar with is retrieving captions for an image. So I was just curious to hear from you kind of qualitatively, where are the models at, like how well are they doing at that sort of task? And what are the main barriers? Is it our ability to build models that understand images? Is it the text? Is it combining the two, or just the amount of data available, or something else entirely?
That's a great question. That's the area that we started off to. We wanted to actually do a wide variety of tasks initially. But then given that like the data preparation and releasing it took some time, we decided to optimize more on picking just one task, showing good improvement on it, and release the data set first so it's useful, and then go back to doing the other tasks. But given that you specifically asked about image text retrieval, the dual encoder models are by far the most popular way to do retrieval challenges. Even when we were doing the two-tower model, already there were the multimodal transformer models. So the bird-based ones where image and text were given combined to a bird model. And we had started some work on that. Like I said, we had to pause that a bit to carry through with this paper first. And lo and behold, that has now taken the world by storm. So there is the multimodal transformer-based models, number one. And then interestingly, vision transformers started happening. So no need to even embed the image, but just take 16 by 16 pixels and group of these pixels directly be given to a transformer model to be able to learn even better. So these models are all like performing way better than what we had about a year and a half or two ago. And that is where it's all leaded. And then of course, now we see models like Clip, there is Dolly, there is Imagine and Party, which even go even further to create images given text captions. So that vision transformer plus this multimodal transformer-based models and diffusion, contrastive learning, all this has taken these models to much greater heights that even cooler tasks are now possible and learning is possible.
Thank you.
Great, thank you so much, Krishna. So we are going to put a pause on the Q&A at this point, and then we may come back to it at the end where we have more time. Thank you so much again for the presentation and all the work. And with this, Gabriel, you can take it from here, please.
Thank you so much, Laila. Laila, I am just trying to share my screen. Screen one, share. There we go. Can you all hear me?
We hear you and see your screen.
Right. Okay, cool. So I am just going to start time here. So hello, everyone. My name is Gabriel. I am going to talk to you now about assessing the quality of sources in Wikidata across languages. So I know it's a big title, but I'm going to walk you through it with some by asking some questions, right? So first is the existential question, like who I am and what do I do? My name is Gabriel. As I said, I am a bachelor in computer science from the Federal University of Ceará in Brazil, and I am doing a PhD in King's College London. I am also a Marie Curie Fellow who's training in a network called Cleopatra. And then, of course, the big question is, why bother with Wikidata reference quality, right? So Wikidata, well, as you might know, is a free knowledge base of structured data. So it's semantic structured data, right? So it's built by a worldwide community of volunteers. So everyone volunteers to add data to Wikidata, much like Wikipedia. But mainly, it's a secondary source of information, which means the contents should be backed by high quality references. That means that if you put a fact in Wikidata, you should be expected to provide a source for that, right? And Wikidata specifically does not ask the claims that it holds to be true. It only asks them to be verifiable. Now it has over 97 million items and has over 1.38 billion statements. So it is quite big, right? This is what it looks like for those who don't know. You have a label, which is the item, and then you have a description for that item. You have aliases, and you have the statements, which are information about the entity, like the date of birth of Diego Velasquez, and you have a value. But more importantly, you have references, right, that tell you where that information was taken from. And it can be taken from multiple places. Why worry about its quality? Well, there has been an explosive growth in data in Wikidata since 2013, 2012 when it was released. There have been multiple agents that use this data, like from Wikipedia, which is the classic usage, but also other places like the Library of Congress, Yale, which is a broadcaster, Google, and even Amazon Alexa use this data. And it's all done by volunteer editors, but there's a limited automated quality assessment. And there are no reliable stats on the actual quality of references. We only know that the references are there. We don't know what they actually look like and what kind of quality they hold, right? And this is very important because the trustworthiness of Wikidata depends on its references. So amongst the graphs we have, for instance, we know that there has been an explosion in statements. This is just from 2016 to until now, and we know that most of them have references. There's a little bit of statements that do not have any reference, but the only thing we know is whether or not they point you towards Wikimedia content. We just know that, or if they point you to elsewhere, but we don't know much more about them, right? So first, and the reason why we're doing this analysis is to try to define and assess quality in Wikidata. So the main thing is to try to define what quality looks like for Wikidata. First, we focus on references, right? Not on truth. So we're not looking into looking at things if they're true or not. We're just looking at whether or not they have good references. And this is taken directly from Wikidata's verifiability guidelines. The idea is that with some exceptions, statements in Wikidata, they should have references that are relevant, right? So the references actually say what the claim says, right? So it's the same information. That these statements should have authoritative sources, which means that the sources that give these references should have the authority to actually say what they say. And also, these references should be easy to access by users. That means that that's different from accessibility, which is, well, for people who have different accessibility needs. This is just easy to access, meaning that someone should be able to go to the source, read the information, and confirm whether or not it says what it should say. Right. So here we define three main quality dimensions. Relevance, which is relevant references support their claims, which is the basic and most important one. We have authoritative, which is considered, we use Wikipedia's guidelines, which normally list types of URLs, types of authors, and types of publishers that normally provide authoritative sources. And also easy to access, which means that users can access and understand relevant information with small perceived effort. This is a hybrid workflow, hybrid assessment, which means that we use both automatic API checks, but also human checks. So humans actually go and look into this information. This has been a study done at scale, right? So it's a 95% confidence interval, 5% margin of error. We looked into many, many references. And we also do that in 6 different languages, not only English. So references that are given not only in English, but also a reference that's given to a website which is written in Dutch, for instance, right? And also we look into 2 different types of references, internal and external. Internal references are references like this one below that point you towards a link within Wikidata itself, like this, stated in Spanish Biographical Dictionary. This, if you click on it, it just leads you to another Wikidata item. And an external reference leads you to outside any other URL in the internet. Right, so first I'm going to show you some descriptive statistics of what the references look like. These are the properties of references in Wikidata. So this is how much each of these properties are used to convey reference information. And you can see that the two, amongst the ones that are used the most are stated in, which links you to an internal reference, and reference URL, which links you to an external reference. Retrieved is just a timestamp. And then we have all of these IDs here, which are just individual identifiers that give you a number to look into another source, right? And then we have these two, which link you back to Wikimedia. So it's a Wikimedia import URL or imported from Wikimedia project. So we can see 4 different main types, right? Internals, externals, identifiers, and then just things linking you back to another Wikimedia project, right? When we look into the stated in predicate, which is the internal ones, we can see that mostly they link you to things that have an existence online. So it's an open access repository, it's a bibliographic database, it's a digital library. And this is very good because this means that if you look into ease of access, right? So if people are actually able to look into this information themselves, that means that most of them have a presence online. So they don't have to physically go to places, right? When you look at the reference URL, which are the external URLs, you see that mostly they point you to places that are like scientific or academic in nature, mostly. So it's EBI, it's NCBI, it's PubMed from Europe, it's Crossref. So these are academic or biological, medical, scientific sources. And this is the main thing. And also it's mostly English, right? We have a little bit of German, but mostly the blunt of it is just English. And then we have some like Japanese, which is under 1%, right? And then we look at the type of references that we're looking into. Mostly it's external URLs. Then there's a little bit of what we call identifier URLs, which are URLs that you can use the identifier that we looked into. And then we have Wikimedia. So these are the 2 main ways to look to link information in Wikidata. One thing we did was we tried to automatically check references through API calls. And this is just the amount that we were able to confirm automatically. For English, 71% of all references could be verified just automatically, just by calling an API, looking at the value for the JSON and comparing it with the value that we saw on the claim. And that's it, that's done. Of course, this varies from language to language, but that's mainly due to the kind of information that each of these languages, when it comes to references, they normally portray, right? And we'll get to that. So let's look at the results of the analysis, combining both the API calls and the results from human annotations. So let's look at what kinds of annotations we got, both from the API calls and also from humans. First, we look into whether or not the reference is relevant. And this is going to be a simple yes or no. Then we look into ease of access, right? We have this ease of navigation, which is how humans perceive the navigation, the access to that information to be free of burdens, right? So 0 is very hard and 4 is very easy. And then we have 6 barriers that we're going to show to you with reasons why they couldn't access the information. And then we have the final one, which is authoritativeness, which involves the type of author, the type of publisher. And then we give a final yes or no to authoritativeness, but we also have inaccessible, which means that people couldn't actually access the URL to be able to say if it is authoritative or not. Right. So looking at these aggregated results, this is a big table, but I'm going to highlight portions of it so that it's easier to understand what these mean. So looking at this one, T1.1. So this is whether or not things are relevant, right? So we can see that this is here for all languages, and then we have a breakdown for each specific language. And we saw that references in Wikidata, they tend to be around 90% relevant. So 90% of all references in Wikidata tend to be relevant, right? Of course, this varies a bit from language to language, but it doesn't vary much. Then we have the perceived ease of access, right? From 0, which is the hardest one, to 4, which is the easiest one. And we see that most languages are either fairly, which is a 3, or very easy to access. We can see here that for all of them, in the all, we have a 34% here and 44% here. So this is a very good sign. That means that references in Wikidata, people can normally go into them and check the information themselves with little perceived difficulty, except for English. And the reason why this is true, and you can see that most of, around 20% of them, which is a very high number, have the hardest one, is because most of references given in English will point you to scientific, academic, and medical and biomedical information, which is something that doesn't happen in other languages that are not English. Main reason being that English is the official language for these things, scientific things, biomedical things. But these sources, they're very hard to understand. So an example is if you link something like a protein that encodes a specific type of like a gene that encodes some specific kind of protein, right? So if you put that in Wikidata, that's okay. People who use that information might understand it. But if you give as a source a page that anyone would be able to look into, they might not understand this, and they might think this is very hard. Likewise, when you have to actually search for the information, which happens a lot too, right, in these kinds of domains, that instead of linking to the information itself, you just link to a search engine, and then people have to actually look for this information themselves. Then we look into barriers, right? So from 0 to 6, we have the barriers for access, and we have the labels here. 0 is page not available. And if you look into Japanese, and this is only for the cases in which there was no access, right? No access granted. For the Japanese, 64% of the cases in which there was no access was because of page not available. And this is because lots of Japanese references point you towards Yahoo Japan, and Yahoo Japan is out of service. So none of these references are ever going to work, and they're still there, and they're very numerous, right? Most barriers, right, from 1 to 4, we look into security issues, credentials needed, paywalls, and domain knowledge, which means that people should understand more about the content so that they can actually verify it. So most barriers do not occur anywhere, right? So anywhere in these languages, we have 0%, 0% here, 0 have a little bit here, 3%, but mostly this is 0. With the exception of English, which has around 6% of issues with domain knowledge, but it also has lots of issues with security issues. And the reason why is because also lots of references government websites that themselves have security issues. And so people they are told by their browsers that they shouldn't actually proceed, and then they just go back and say, well, there was a security issue. And this happens a lot. But most barriers were legitimate lack of information, meaning that the reference just wasn't relevant. They were able to go into the source, they were able to read all of the data there, but they just didn't find anything that supported the claim. And this is something that me and my supervisors in the PhD are looking into for future work. We're looking into ways to automate this kind of verification if the source actually backs up the claim. But this is the main reason why sources in Wikidata are not relevant, right? Then finally, we look into authoritativeness, which is what kind of author and what kind of publisher is given this data, these sources, and whether or not this is authoritative. If you look into this one, C means collective, which means that the author is a collective. And if you look into S here, the publisher is S, which means self-published. So these two columns here identify sources that were collective and self-published, which describes Wikipedia. And these are basically the sources that point you towards Wikipedia. And they are all regarded as non-authoritative. And this is something that Wikidata itself in the guidelines say that Wikipedia sources are not authoritative because they are just self-published and they are made by a collective of anonymous individuals. So they're not actually authoritative. They should just link towards other places, but they're still used as sources a lot. You can see, as I was saying, that in English, in the language English, even though for all languages combined, academic publishers are only 22%. For English, it is about 83%. So it's very different from all the other languages, especially Japanese, for instance, which is 1%, and Swedish, which is like nothing. Swedish and Dutch, for instance, link a lot to museums and heritage websites, but not to like scientific information. So what are the takeaways from here? References are in general moderately to highly accessible, right? Levels 3 to 4, except for English, as we saw. And 2/3 of all references were deemed authoritative. Yes, if we go back here, I'm sorry, I skipped that. If we look into the yes or no, into whether things are authoritative or not, we see that for all languages, 2/3 of them are. Yeah, so that yes, they are authoritative, but there is a big portion of sources in Wikidata which are not regarded as authoritative, right? And this is quite large, 30%. yeah, so this varies from 52% to 90% based on the presence of Wikipedia references. This is the major impediment towards authoritativeness, right? Even though, and we'll see this in the next slide, Wikipedia references are the most relevant and they are the most easy to access. So if you disregard completely the authoritativeness side, they are the best references, at least from what people, right, the human annotators thought. Around 90% of all references in Wikidata are relevant. And interworker agreement, we don't need to talk about this. But just to say that when people annotated these references, external references were much clearer to the workers than the internal ones, right? So moving people towards an external URL worked much better than just keeping them in Wikidata or just giving a link that is represented within Wikidata and then giving some sort of identifier for them to look for it themselves. And also quality variation between languages, the quality meaning those three measures and dimensions that we saw, is very tied to domain variability. So for instance, in Japanese and Portuguese, sources link you a lot to information about football players in Wikipedia, right? Whereas in Wikidata, in English, it links you a lot to scientific information. But in Dutch and Swedish, it links you to museum data, right? And like artworks. So it depends mostly on the kind of domain of the information rather than the language itself, as is expected. So some discussion points on improving provenance representation. So Wikipedia references are the most easy to access. So 77% of Wikipedia references are a 4 out of 4 in ease of access, and 98% of them are relevant, which is much higher than the general aggregation of all references. So what we saw from the workers is that direct URLs combined with external identifiers are the best option. So not only linking you directly to a source, but also if there is some sort of identifier that people need, also giving that to them. So giving both things. Also, a considerable portion of these references can be automatically verified, right? So we saw with the API calls, like most of English references could automatically be verified just by defining what in that source's structure, what kind of position on a JSON or whatever actually maps to the relationship being used in Wikidata. And then you can just automatically verify all of these. Link rot is very present, as we saw with the Yahoo Japan problem, but this might also be automatically verified. And these claims and these statements can then be put on caution, saying, well, hey, this reference is suffering from link rot, it has been displaced, or it has been severely modified. And then harder cases of relevance verification need a sophisticated NLP pipeline, which is something we are currently investigating. And then content across languages, it's very tied to trends in content. So differences in quality of references in different languages is much more tied to the trends in content, as we saw. And that communities, they should both focus on the overall graph and there's order, but and ensure domain specific quality. So ensuring that information about that specific domain, about that specific kind of like that, if you're looking into astronomy information, for instance, you should ensure that that has quality, but that this might be verified by people who do not know about that domain and who are looking at it from elsewhere. Of course, there are limitations in this study. The crowd is always biased, so whatever crowd we use to annotate this, it has its own biases. And Wikidata is volatile, which means that if we run this same analysis in 2 years or 2 years ago, we might have different results because Wikidata is changing every day. So with that, I would just like to say thank you. Thank you for watching this. Thank you for the word. Thank you for reading this research, and also thank you for looking into, tuning into ways to improve reference of Wikidata claims, because I think that's a very important thing. And I'm going to stop sharing the screen.
Thank you so much, Gabriel, for the presentation. I see that we already have questions in the room. So Diego, maybe you can kick us off.
Sure. Gabriel, thank you very much. The presentation was super interesting. I've been working in similar spaces, so all that you presented today was very valuable. I was wondering if you have done any study related or to the users that are adding these references, because in Wikidata there's a lot of like manual edit, but there's also a lot of like huge imports of other databases. Then so you have some bots that
Yeah.
takes people taking one databases and importing to Wikidata basically, and I'm
Right.
wondering if the some of the results that you show here could be affected by some specific users, by some specific data imports that are introducing some of the problems or the good things that we see here. For example, we know that WikiCite is a huge project inside Wikidata importing these scientific articles. So probably
Yep.
many of the
Yeah, no,
things that you
that's
see around scientific articles depends on what they are doing. So yeah, that's my question. If you have thought
yeah.
about this.
No, that's a great question. And yes, you can even see it when we look at the graphs and to what kinds of domains like external references actually linked to, and you can see that it's mostly things like crossref, which is basically just citations of scientific papers, just like linking who cited who, and yes, there's lots of work, for instance, with the people in astronomy, like the astronomy project, who just links, like, try to like get all of this information about astronomical bodies, and this can bias the results, and this can create like these bubbles of domain knowledge and domain information that might skew results. This is one of the main reasons why we looked into this, trying to separate different languages of contribution, not because we thought there are going to be like innate differences in quality, but we thought if we look into other languages, we might be able to easily bypass these kinds of just bubbles of information, which are mainly linked to English. And we can see that when we look into the data quality in English, it follows a completely different kind of pattern and profile than the information in other kinds of languages. Yes, this can happen, but as I said in the takeaways, if this kind of information is being borrowed or imported automatically, that also means that you could try to look into these references or perform some sort of reference control automatically. And also you could employ some sort of metadata that says, look, this kind of reference control was evaluated or was done on this date, maybe in a week, maybe in a month, maybe in 6 months or a year. Try to check that again, because this was automatically borrowed and anything might have changed in the process. So this could be it could be a good idea to try to just try to run this again. But yeah, it's, for me as a researcher looking into this kind of research, it would be very easy if I could just automatically see what kind of domain each of these claims belong to, even though we think, oh, that's very straightforward, we can just look into what kind of entity it is. It isn't. It's the data is very entangled. But yes, if you want to look into kind of like editors like bots and humans, you can look into the research done by my co-authors, Alessandro and Lucy. Lucy specifically, she's done a lot of work into I think so workers and bots and who actually edits Wikidata, which is very valuable. Cool.
I know Diego has more questions potentially. However, I want to just give others a chance if there are any other questions you want to ask. Okay, then Diego, you should go ahead with your next question if you have another one.
Yes, I was wondering also if in this study you had a sense on reference removal. So basically, how often references are updated or changed. So if it really exists this process of reference checking, and if there's people in the community that is
Right.
focusing on that, or if this is something that I don't know if you have seen something about this, but that would be very interesting, because basically you are proposing some ways to improve that, but I don't know, and I don't know. It's a completely open question. If it's really there's a lot of, or there's some part of the community that is focused on cleaning or improving references.
Right. I did not look into the activity from the community into how these references are updated, cleaned, or removed. We did start from the principle that there are just too many references for this to be feasible at a large scale. And then we thought, okay, yes, some people might be looking into these, but if so no one is going to do this at that scale. They might be able to automate this for, like, as we said, for the claims that are automatically created. But even then, if you exclude those, there's lots of things that are just manually created as well that would need. So first of all, they need references. So you need people to actually put the references, because some people just forget to put them when they put the information in the claims, and then you need people to check those references. And so it's a big chunk of work. Right.
I have a question for you, Gabriel. If you consider, like, from the beginning of this project, where you all started thinking about what is the exact research questions and, like, what is the space that you're going to explore, all the way to today, when you're communicating about the research and trying to advocate and raise awareness about the learnings of it, what were a couple of challenges that you faced that you would like to surface here? And it can be that you have found ways to address them, or that you're still facing them and you want to help others be aware of them, or help you address it.
Right. So when we began the research, we were looking into. So the way we began was like, let's try to create a model that checks references, and then we realized that, well, for that actually to be anything near feasible, we actually need to check what references actually are, what they look like, what actually it means for them to have data quality. So that was a big thing, what actually it means for references to be good. And I took a lot of from the notes from Alessandro, one of my coworkers, who had looked into this as well, and trying to see, okay, these are the dimensions we should be looking into. And the second thing that actually still is open and still is quite big is that even now, finishing the PhD and finishing this the pipeline approach and the models, the more I look into it, the more I realize it's a huge problem, because yes, you can create some sort of language model pipeline of just huge monsters that are just like chained, and each of them is like a huge, large pre-trained language model, like a BERT or something. But there's just so much information in Wikidata. There are so many kinds of web pages and resources that are linked. There are CSVs and JSONs and PDFs, and there's information on art and information about soccer. How do you possibly cover all of that when people themselves can't really? It's 1.38 billion statements. That is a lot of ground to cover, and so it's just this thing about it's a big question, right? So.
And I see nods and smiles in the virtual room. Any follow-up comments on this from the room?
There are, I think, 2 questions on YouTube, if I'm seeing the chat correctly.
Sounds good. Thanks for your response, Gabriel. And Isaac, do you want to share the questions?
Yeah, we have, excuse me, we have 2 questions from YouTube. The first one's from Alberto, and he asked whether there's any data about circular references inside Wikipedia itself. And I think this often goes under the name like cytogenesis, but the idea for folks who aren't familiar of like Wikidata has something, for instance, maybe that says imported from Wikipedia. If you go to Wikipedia, right, you see Wikipedia itself pulling from Wikidata in that sort of pattern.
There are lots of anti-patterns in Wikidata, and yes, this one actually occurs a lot. So what, for me, was the biggest issue was with the info boxes. So currently, when I'm looking into these tools that try to look into the sources to then parse the sources and check if they're relevant or not, I realize that lots of the sources link you to Wikipedia, right? And then lots of these claims just claim information that is on the info box of these Wikipedia pages. But the info boxes on Wikipedia pages are created normally with information from Wikidata. But for instance, there is this musician called MOG Music, and there's this claim that says that they began working in 2013, and then the source is Wikidata, so Wikipedia. So we go to Wikipedia, and there it says that they started working in 2013, but that's in the info box. But in the text itself, it says that they started in 2016. So or 2012. It's a different year. So so the person who filled the information, instead of relying on the text of Wikipedia, looked into the info box, but the info box information comes from Wikidata. So yes, that happens, but also other kinds of anti-patterns also happen in Wikidata, like just information that links to itself. It's not like a pressing concern. It's not like something that happens all the time. From like all of the references that I constructed my data set with, that was the only example that I could find. But it happens. It's a thing that happens.
Well, that's actually a nice, I think, segue into the second question from YouTube, which just whether you identified any misinformation, because it sounds like to me what you're saying is that's probably not a good pattern of this like circular loop thing, but maybe when it gets it wrong, it's not so wrong, or oftentimes the content still is right, even if the verifiability maybe isn't there. But yes, so then with misinformation, were you seeing any instances of that?
So misinformation, so just by following rule of three, right? I can name you 3 kinds of misinformation cases. Again, from the data set that I created now in more recent work, trying to construct claim and reference automatic verification. One is the page has been updated, but the claim hasn't been. So sometimes a page that was destined to a ship, for instance, that says the ship's tonnage, the ship's flag, where it comes from, has been repurposed for another ship for whatever reason, but that page hasn't been changed. So although everything is correct, right, the claim is still true, but the reference, the URL no longer has anything to do with it. So that would be like the first option. First type. Second type is just information that is wrong. Someone read it wrong. Someone manually annotated and read it wrong. For instance, a date of birth that isn't actually what it says on the original document. So someone says that someone was born in 1875. You go to the document, it says 1873 or something, right? There's that. And then there's the other one, which is, yes, information that has been purposely put wrong, but then that's something that has to do with what was the name for it? It escaped me. But it's when people actually go and they try to vandalism. Yes. So that's more linked towards vandalism, which is something that I don't look that much into.
Can I ask, building on this, is there like interventions or like simple interventions that you could think of that could help like flag any of these pieces, or does it feel like, I mean, what you were saying earlier, which is it's just a very complex problem?
Right. It's a very complex problem. The only thing that I can think of, like within my pocket of research, is sometimes these sources and these references, the content in the websites change a lot. And something to track that kind of change, I think, could flag lots of issues. So if you have a website that is structured in a way that you've linked, yes, another issue, sorry, references that link you to the homepage of a news source. So that's never going to be anything useful. So it could be saying, oh yes, this person died, and then you link towards the homepage because at that time the homepage had like breaking news, this person died. In a week, that's not going to be that anymore. So anything that just tries to detect whether or not content has changed on the page, like in a constant way, or in like huge spikes of change in the content of the pages, might be useful and might be able to flag a reference that is no longer doing what it should be doing.
It's actually a really interesting point. I wonder if we have any Internet Archive folks listening, if they've thought about that. As somebody who, scrapes pages quite often, might know that.
Yep, that's it.
Thank you so much. So we are approaching the end of the call, or the presentations and showcase. I would like to just maybe open the floor up for questions for either Krishna or Gabriel. If there are any remaining questions, please ask. Krishna, I have one question for you, which is the paper has received more than 40 citations so far, and I won't assume that you know all the different work that is done based on the research, but is there any particular work that is done based on the data set, other than the Kaggle competition that which you presented about, that is interesting for you as a use case of the data set, or something that you want to highlight?
So there are like a couple of benchmarks that were recently done. So the text stack has this benchmark called glue, and then they did super glue. So similarly, there is a iGlue benchmark that our collaborators from across the world research, they came up with, and the WIT dataset was part of that. So that was pretty interesting to see for me, is like to have this hard, challenging tasks as part of a benchmark. And then beyond that, there were like a lot of pre-training strategy related papers, and we were super glad about that because that was precisely what we were targeting. So this kind of becomes this big general knowledge repository that goes into the pre-trained models, and then for whatever the downstream task individually when folks want to do, they could do. So there were like 3 or 4 papers on that. There was one interesting paper that called out about how if you do just like general public web crawling and collect set, there could be a lot of unwanted content that could seep in. And in that paper, they had called out WIT on the good side, saying, oh, look at the WIT paper, which did all this curation and filtering and do something like that. So that was again like very thankful for all the things that we did, but also like a good marker to remember when curating this big data sets. So yeah, those are the works that come to mind top of my head.
Great, thank you so much. And I see Miriam's hand is up.
Yes, yes. I wanted to ask one last question that might connect the two general topic, and I think it's mainly for Krishna and Gabriel. I want to hear your thoughts as well. So the WIT dataset already connects to very important word that hasn't necessarily been exploited in multimedia and computer vision and natural language processing technologies, which is the text on Wikipedia and the images on Wikimedia Commons. And you mentioned, Krishna, in the presentation that there are about 600,000 entities in the data set, right? So I think the next level of the WIT data set is connecting all of this to Wikidata. I mean, I imagine a world where we could do this connection. And I'm wondering, like, what do you think this would enable in terms of potentially new applications or technologies if we were able to add a third modality, that is the structured data, to the WIT multimodal data set?
Yeah, I can start maybe, and then Gabriel can chime in. My aim is always like kind of be able to answer questions very well. For example, like right now, the tasks are always like, oh, this is a dog playing with ball on the beach and things like that. But I would want to like give a picture and then say, oh, this is President Obama and some other important personality standing in front of the White House. To be able to infer all these things, you need that connection. Oh, this is a president and his name is this, and this is the place where they live and the offices, and connect all these multiple things and which year it happened. Maybe it was a very significant political movement that happened along, and to join all these multiple things, so you go beyond the image text and the page, and then now to this structural knowledge that's part of Wikidata. So that I think would be a super cool task to build upon, and also that could be like one of the things which could become a good competition, because you have the human edited data that is coming in as answers. So you know what the answers are. If you can figure out the questions and hold back some of the answers, that is like our next competition or challenge, that then we can generalize to building even more cool stuff.
I completely agree with Krishna. And I think that there is in my opinion, so I see a great benefit, but I also see a bit of an issue. So the benefit is, if we look into the images, right, and their captions. So right now in Wikidata, we already have a way to connect different entities through semantic information, saying someone is married, like directly married to someone, or saying someone is a head of state and someone else is also head of state, and these countries have relationships. But if you have images of people standing side by side, if you have images of things happening and people present in them, and you annotate these images with the labels in Wikidata, then there's another way, especially with the captions. So if you also annotate the captions, there is then a new way to create links within Wikidata from entities to entities, which I think can be very enriching to entity and entity relationships, that can aid extractions, that can aid embeddings, and lots of things that you can do with knowledge graphs. The issue that I see, and that is again with the idea of like provenance that I just explained in presentation, is that the information from Wikipedia again is not seen as authoritative. So you would not be able to just trust the information that is put on Wikipedia. The thing that I see the most is like, okay, we see this kind of resource and we see that it's being used a lot by lots of these, like lots of companies and benefactors, but what if people realize that that's very important, right? So what if people realize that by putting images in Wikipedia, they can severely alter how a specific entity is seen in the knowledge graph in Wikidata, and then that impacts the embedding, which also impacts the way that it's used by downstream applications. And then that really opens the window for people to just be mean sometimes. And so that idea of ensuring authoritativeness is very important, I think, in this kind of case, when you begin to factor in and merge all of this information that is voluntarily created, there has to be some sort of check, right? But I think it's very powerful.
Thank you so much, Krishna and Gabriel, for your responses, your presentation. We are at time, so I'm going to close the session here, thanking you again for being here. Congratulations on winning the award. I also want to thank those of you who engaged virtually as the presentation was going on today, or if you're watching this video later, thank you for keeping an eye on the Research Showcase and the research activity on the Wikimedia projects. We look forward to hearing from you. I also want to thank Emerald, who has been supporting us with the technical support for this session and many of the other Research Showcase sessions that we had. Isaac for helping us with the Q&A. And as a reminder, next month, we are not going to meet for the research showcases. We're going to instead attend Wikimania virtually, August 11 to 14. Please check it out and attend. And see you all in September. Thank you.
Thank you so much. Thank you. Bye.
Thank you, everyone. Bye-bye.